Let's do it.
Hi, good morning, everybody. Happy Friday. I'm John Scripter. This is Garrett Hansen. We're going to talk to you today about a solar-powered product recovery system called our Solar Sipper. And so I think we're able to just get started. Solar Sipper was developed in 2000 to use at railroad sites to clean up diesel tank spills and leaks. Developed for sites with no electrical power. And we did a redesign in 2011 for multi-wells. We can operate up to 8 wells out of one control panel. The original Solar Sipper was a single well unit only. The applications for this product are basically product recovery, LNAPL, basically gasoline, diesel, jet fuel, up to number 4, maybe a little bit heavier depending on what the viscosity of the product is. And we also have a DNAPL application as well. Put a fixed intake with a connectivity sensor in the well so you can recover heavier than water, basically chlorinated solids. Not really creosote or anything like that, but chlorinated. And we can also do a total fluids recovery with a nondescript fixed intake to do separation above ground. And it's designed for 2-inch diameter wells and larger. So solar power rules of thumb. Basically, it takes 100 watts, which is a square yard of a solar panel, to operate a 1/8 horsepower device. In the case of the Solar Sipper, it has a built-in air compressor that is a 1/8 horsepower motor. 35 amp hour battery will give you less than 5 hours of operation with a 1/8 horsepower load. And it takes 5 yards or 5 solar panels, 500, 100 watt solar panels, and 4 batteries to run that 1/8 horsepower on a continuous daily basis. So the available energy is based on average, what your average daily sunlight is, depending on where you are in the country. And we determine this. I'll show you a map here in a second, based on where you are. And the expected majority of the recovery is during the summer months because that's when we have the most sunlight available in the US. So this map here shows basically the average yearly sunlight in the US. You can see the Southwest, bright orange, they have the most, and the northern part of the country has the least. And so we use this map along with the product you're recovering, how many wells you're pumping from, and the amount of product you're expecting to recover to design how many solar panels, how many batteries you need to operate the system, so you can operate it 24 hours a day. The advantages, obviously, it's a green energy, green technology. You can reduce your carbon footprint. You don't really need to drive to the site. We offer a telemetry option so that you can monitor the system from your office. It's for sites, obviously, with no electrical power or sites that would be very expensive to drop power load in the area that you need to do the recovery at. It's a compact footprint, and with the skimmers that we supply with the system, we can recover water-free product into the recovery tank. There's no expensive compressed air bottles because we supply an air compressor in the control panel. And we can recover higher viscosity product up to 90-weight oil with a modified heavy oil intake. And as I mentioned before, we can do DNAPL, chlorinated solvents with a fixed intake and connectivity sensor. So when we're designing a system, we look at the recharge rate of the product layer in the well. So you'll need to do like a bail down test and then determine how long it takes for the product to rebound in that well. And we use that data to design the system. We also look at the seasonal groundwater fluctuations, the type of product you're recovering. Is it light fuel, is it gasoline, or is it heavier fuel that is more of a strain on the compressor itself? Also the number of the wells that you're going to be operating. And we recommend, and this is based on the size of the airline that we recommend that the controller is within 500 feet of where the skimmer is going to be, skimmer and pump are going to be in the well. And also, last but not least, where you are in the U.S. or where you are in the world, based on what your sunlight availability is. So I'm going to let Garrett take it from here. And I also want to mention that if there's any time when we're going through this, if there's any questions at all, I want to make this back and forth as informal as possible. Raise your hand, speak up, rather than wait until the end. You know, if you have any questions, please.
Yeah. Like John said earlier, it's for 2 or 4 inch diameter wells, but you can install it in larger wells as well.
Right.
It's got a hydrophobic membrane for the product intake. It's selective, so you don't recover water as well, and it floats on that on the interface. So that's why we take into account the seasonal fluctuations. If you're on the coast, that can be something to consider. We can get that product down to a sheen with the sipper system. We've got NEMA 3R controls, so the panel is weatherproof, and it's got a built-in air compressor. We do have solar panels that we can size up according to your location and how much power you're going to be needing based on however many wells you're going to be recovering product from. And multi-well systems. So we can recover with this system 0.2 gallons per cycle. So every time it discharges product, if the pump is full and we have all of our timers set properly, you should be getting about 0.2 gallons per cycle. The max operating depth is 180 feet for the solar sipper. We do have another system actually that I just sent out. We're recovering product from, I think it's like 250 feet. But the client is using their own air source for that. So we have options. Let's see, power requirements. You need some batteries, and the maximum vacuum is 20 inches of what is it, mercury? Yeah, and the maximum pressure is 100 psi, which is why the operating depth is 180 feet for that little compressor in there. Let's see. So the system will come with, I'm going to use my laser pointer, with a tank full shut off. So you can, so it'll turn the system off, you know, obviously when your tank is full. That's a handy feature to have. And then your pressure, let's see, vacuum compressor. Yeah, these are just all the components that come with the system to recover product. Yeah, so we kind of covered this a little bit, but we'll continue on. So we can do 8 wells. We can provide product recovery tanks in the form of a 55-gallon steel drum, and there's other options too, right? If there's if it's needed.
Yeah, we have sites where client is operating multiple wells, 5 or 6, maybe up to 8, and they want to have a recovery tank for each well so that they can measure how much product is coming from each well. And so we can, the standard system comes with 1 tank full probe, you know, shut the entire system down because we're assuming you're pumping into 1 tank. But if you're pumping into several tanks, we can offer additional tank full probes that would only shut off that particular well, leaving the other wells operational as long as the tanks are not full.
Mm-hmm. And then we also have dual containment. What is it?
It's called a hazmat container. We got pictures of it. We'll show you here shortly.
Mm-hmm. This is it. There's your panel, and you can install that in whatever way you need to get the most sunlight, right? The most power. Here's the skimmer assembly. So that allows it to float on the interface there. And it can also keep up with those tidal fluctuations.
Yeah, the 4-inch model has a 2-foot of travel range, and the 2-inch is a 1-foot travel range.
And here is a diagram of your typical installation, I guess. We've got the product layer here, and I guess I can use my laser pointer. And then your product intake, here's your groundwater. The pump is actually above the intake, and so there's 3 cycles. There's a pressure cycle, a vacuum cycle, and a delay. And so the vacuum cycle will draw product from the intake up to the pump. The pressure cycle will discharge the product to your recovery tank. And then the delay is how you will program it to, keep up with your recharge rate.
Right. Basically, the delay, the system would set idle, and that time that we wanted to set idle would match what your product recharge rate is in that particular well. And if you're running multiple wells, we can set up those timers different for each well.
There's the panel. This is just a diagram of how you can cycle through all the different settings and stuff like that.
That's included on the inside door of the controller, so that you can step through, and it just walks you through how to do the timer settings and start the system up, basically.
And you can look at there's a cycle counter, so you can figure out your rate of recovery, based on how many times it's discharged and stuff like that. So you can figure out, where you're at. So like I was saying, the vacuum cycle is what's drawing the product from the intake up to the pump. And you can set that anywhere from 0 to 30 seconds, but that timer should be relatively short, right? Because you're only going a small distance from the intake to the pump. The pressure cycle is what pushes it to the tank. I kind of got ahead of myself here. I already explained all this, but and you can do a pressure cycle up to 4 minutes. The delay can be set from anywhere up to 24 hours, like we were saying, to match the recharge rate. And you can vary the settings dependent or for each well. And we covered this 0.2 gallons per cycle.
Yeah, and what 0.2 gallons is, it's basically the capacity of the canister pump. 0.2 gallons is roughly a liter. And in a 2-inch well, 14 inches of product in that well is equal to 1 liter, or 0.2 of a gallon. And in a 4-inch well, it's 3.5 inches of product. So if you go to the 2-inch well and you say, I've got a foot of product in a 2-inch well, you think you have a ton of product. Not necessarily. If it recharges fast enough, then obviously you've got more product in the plume that's coming into the well. But that just gives you an idea of how much product is based on how much product you have in the well, what you actually have.
And then you don't want to remove all of the product from the well on each cycle, right? Because you want to keep that that product flowing into the well. If you remove all the product, there's a chance that it might not recharge.
Correct. You'll break the connectivity, and so you'll keep product from coming into the well. So when I'm explaining to customers or setting up a system out in the field, I try to take more of a conservative approach. Rather than set the vacuum timer and fill the pump up completely on each cycle, we'll fill up maybe halfway or 3/4 of the way so that we don't take all the product out. And also, with that vacuum cycle, if you vacuum for too long, canister pump will overfill and there's no place for the fluid to go to, but into the airline. And eventually that'll get back to the compressor. You don't want that to happen. So you don't necessarily need to fill the pump up on every cycle.
All right. So these are just, this is a general example of setting up your timers. So we've got a scenario here where we've got a 4-inch well with 6 inches of product. Our depth of water is 10 feet. The panel is 25 feet away, and the recovery tank is also 25 feet away. And then we've got a recharge rate of 6 inches every 2 hours. So in this scenario, we'd want to set our vacuum timer to 5 seconds, our pressure timer to 30 seconds to make sure it adequately gets to our recovery tank. And our delay timer is 2 hours. And that was supposed to be a little quiz for you guys, but I just gave you all the answers, so. But the reason that we have these settings is because it's shallow, and we don't want to over pressurize the system. We have short tubing runs. Each pump cycle is 0.2 gallons or 3.5 inches of product in a 4-inch well. And we don't want to pump all the product out, like John was saying. And let's see. What were you telling me yesterday when we were talking about this? Let's see.
Well, we've established that in the site parameters, we established that the recharge rate was at 2 hours, and that's the reason we set the delay timer at 2 hours, just to match what the recharge rate is in the well.
Yeah, exactly. So based on the example that we've given, we can, for every additional 25 feet of airline after the initial 25 feet, we can add 2 seconds to the vacuum timer to make sure that the air is to make sure that the product is getting into the pump, and then 3 seconds to the pressure timer, or whatever pressure is needed to get water to the recovery tank or product to the recovery tank. These are some cool examples of some systems out in the field, very remote, location here. There's no power. It's too expensive to run power lines out there, so we've got a solar panel.
Yeah, this is an option that we build quite often. It's a hazmat container with 2 55-gallon drums of secondary containment.
Yeah, right.
The controller is mounted on the outside of the unit itself. Basically, you drop the hazmat container at the site where, close to the well or wherever you want to put it. Connect 4 wires from the solar panel and the battery. You're up and running in half an hour.
Trailer mounted system, so this is very portable. That's a cool setup there.
Yeah, we've got a site where the client wanted to move it from well to well because it was quite a large site, so it was too much of an area to put a centrally located control panel and run air lines out to each well. So they were just going to move it, periodically from well to well. And so we set it up on this trailer with a solar panel on a bracket that they can put at whatever angle they need to put it at to get benefit from the sun. And this has a recovery tank built in right on top of the trailer itself.
Oh yeah.
This is a site that I've been to a couple of times. It's the Hansen site in St. Croix. We've got 25 of these sites set up very much like this. Basically, they put poles in the ground. We mount the controller. The batteries are in an enclosure on the bottom underneath the control panel. Everything is mounted onto a pole set right next to the well that it's recovering product from.
Yeah, you got to go down to the Virgin Islands, huh?
Yeah.
site in New Mexico. You want to tell us a little more about this?
This one I wasn't really involved with, but again, they have, you can see they have 2 solar panels in that bottom right-hand picture because they're operating multiple wells. I think they're actually, they have a lot of product there, so they're cycling the system quite often, so they needed the additional solar panels, additional power to keep the system up and running. And it's just another site, let's call it Leopard site, and again, they got just a large recovery tank and a multi-well controller mounted next to the tank itself, and they're just running air lines out to the individual wells. So that's
Questions?
yeah, everything that we have here. We went through it kind of quickly, but if there's anybody have any questions? Any sites you might think this be?
So.
We were on the factory tour. He was showing us these and saying that there's like remote telemetry for it to tell you when it's full.
Yes.
I'm wondering, it has that in a 2-inch well, it has that foot of float. If it's outside of that, it's unable, it's not pumping any product because the water table fluctuates beyond that. Is there any way for it to notify you of that? Or would you just have to have someone go out there and check it?
Right. We don't have a sensor in the well to be able to tell you where the skimmer is in relation to the water table. So you would have to have someone. I mean, you can we can put sensors in the recovery tank to see if any of the level has changed in the recovery tank, and you could use that data to determine whether the system is pumping or not, and then send someone to the site.
Anything else?
Yeah.
Does the solar panels move on their own?
They don't move on their own. You would set them at the angle that you want them at based on where you're installing the system and where the sunlight is in relation to any trees or buildings that are around.
That would be cool though.
Yeah. It would be nice to be able to remotely move it, but we're not there yet.
So I'm assuming the pump, like it just cycles through. If you have 8 wells, it just runs one at a time.
Correct.
Okay.
And what we should mention is that pump is not really a pump. There's no moving parts inside that. It's a canister. It's basically an empty canister with a check disc on the bottom and a check valve on the top. And so very low maintenance. But yeah, the system will, when you first start it up, say we're running 8 wells, it'll cycle through all 8 wells one at a time. And then it will go through and look for the one with the shortest delay left, go to that well, wait until the delay is done, and then run its back pressure cycle. After that's done again, it looks for the shortest delay on the next one. Okay. So it's running one pump at a time. And as I mentioned before, you can set, you've got wells that some wells are recharging faster than others. You can set their timers differently. That way you're not cycling them all the same way and pumping water out of some wells and product out of others. Anything else? Any other questions?
I think we're good on time. Thanks.
All right.
Cool.
Thanks, everybody.
Thank you. Thank you.